Hi folks, we're going to take a look at page 347, number 21. So here they give us these three vectors A, B, and C defined using the standard basis vectors, and then they want us to find the magnitude of this combination of vectors A, B, and C. Now just to make my life easier, I'm actually going to rewrite these vectors in coordinate form. I just find them easier to work with, so nothing stops us from doing that. So here, if it's 1 times I plus 1 times j minus 1 times k, that means that our point can be written as 1, 1, negative 1. So remember that the coefficients of I, j, and k just represent your three coordinates. Okay, so then b is going to be x value of 2, y value of negative 1, z value of 3. And then here for c, so our x value is going to be 2. Now there's no j. That must mean that its coefficient is 0. So it's going to be 0. And then 13k, so my z component is 13. Okay, so from here I think it's going to be a little easier to solve this problem. So I'm not going to show every little step here. So I'm going to do some steps in my head. Okay, so here I've got 2 times, and I'm multiplying the vector A plus B minus C. So I'm going to try to do this in my head here. Okay, so I'm adding and then subtracting. So 1 plus 2 is 3, minus 2 leaves me with what? X equals 1. Okay, this is 1 plus negative 1, so 0 plus 0, so that remains 0. Negative 1 plus 3 is 2, and then minus 13 is going to be negative 11. All right, so let's move on to the next one here. So minus, and I'm adding A plus 2B. So 1 plus 2 times 2, so 1 plus 4 is 5. Here 1 plus 2 times negative 1, so 1 minus 2 is negative 1. Okay, and then negative 1 plus 2 times 3 is 6, so negative 1 plus 6 is 5. Okay, and lastly, it's 3 times, okay, and the vector here is going to be A minus B plus C. So 1 minus 2 is negative 1, plus 2 is 1. All right, so here 1 minus negative 1, so that's 2. Plus 0 is 2. All right, and lastly here we've got negative 1 minus 3 is negative 4, plus 13 is going to be 9. All right, so now let's keep simplifying. Okay, so now I'm going to combine these three vectors that I've got here. So this is 2 minus 5 is negative 3, plus 3 is 0. All right, let's do the y component. So 2 times 0 is 0, minus 1 is negative 1. Minus negative 1, so it's going to be plus 1. So 1 plus 6 is 7. All right, and lastly we have negative 22 minus 5 is negative 27 plus 27. So this one's also equal to 0. So now I just have to find the magnitude of this final vector. 0 squared plus 7 squared plus 0 squared. I think you can see where this is going. So the square root of 7 squared is just equal to 7. And there's my final answer. Okay, so just to recap here, reminder that I, j, and k, now the textbook doesn't use the hat notation. I would be using the hat notation to indicate that these are our three standard basis vectors. So to make my life easier, I just found it better to rewrite these in coordinate form. And then from there, I just simplified the expression inside the magnitude. And then from there, once I found one final vector, I was able to determine its magnitude. Okay, that's it to this one.